Hello everyone, I'm Jimei Hu from Harvard. Today I'm going to talk about a novel way to improve data scientist efficiency with provenance. This is a joint work with Jiwon Zhang, Maya Jacobs, Krzysztof Giles, and Margot Seltzer. Everyone knows that data science is important. Data scientists frequently analyze data by writing scripts. They typically arrange their script into an iterative procedure which consists of editing the script, executing those scripts, inspecting the results, exploring parameter alternatives or debugging, and then editing the script again. Meantime, parameter tuning accounts for the majority of development time, and debugging is both time-consuming and cognitively demanding. So, how can we make script development and debugging procedure more efficient? We make a hypothesis that isolating and streamlining the piece of code that the users are working on can expedite data analysis process. So we developed ProfViews, a tool that uses change impact analysis to improve script-based workflow. In particular, we use language-level provenance, which records information about every line of code executed by a script, to identify the dependency between all data objects. In order to help reduce programmer cognitive load during debugging and decrease the subsequent execution time, ProfViews pinpoint which part of program and statement must be re-executed to produce the new result, and generate a shortened script called ProfScript that containing only the section relevant and affected by a modification. The purpose of generating these short scripts is to make it easier for the user to reason about their code. We evaluate our work with 3 studies. So first, I will show you a toy example. This toy example shows how ProfViews works. The left script shows the original script that we are trying to debug. Assume that debugging target is function bad in line 5 and 6. ProfViews utilize no workflow to collect Python provenance. We will explain it later, and analyze dependencies relevant to this target bag. Then, ProfViews generates the shortened ProfScript on the right, which only contains the definition of bad and the subsequent assignment relevant to bad, which is line 9 and 14 on the right. Other irrelevant variables are treated as constant, which is line 1 to 4 on the right. As we mentioned before, ProfViews use no workflow to collect language-level provenance for Python scripts. With the generated Python provenance information, ProfViews constructs a provenance graph for the debugging target. Given a target, we divided the execution provenance of a script into upstream provenance, which is everything on which the target depends, and downstream provenance, which is everything that depends on this target. ProfViews iteratively collect those dependencies and include them in the ProfScript. Meanwhile, provenance is execution trace information. So there are some aspects of the script that ProfScript needed but is not recorded in the provenance, such as control flows. Including every possible function would lead it overly complicated ProfScript. So ProfViews developed an iterative exception handling method to ensure that we are not missing anything and we don't include it unnecessary part. ProfViews also use automatical integration. ProfViews also automatically integrates changes into the original script. We also show a simplified ProfViews interface here, which contains the major functionality of ProfViews. Search for specifying debugging targets, and then the our ProfViews will generate a shortened ProfScript for the user. Execute for executing the modified ProfScript, and merge for integrating the changes to the original script. We also use this interface for user studies. Our first evaluation is a controlled laboratory user study. We use multiple hypothesis p-value testing to validate 3 hypotheses. ProfViews will decrease task completion time and user cognitive load. The user will subjectively prefer to use ProfViews. We can conduct this study with 21 participants and 4 debugging tasks for each one. For more study details, please refer to our paper. The p-value result shows that the difference is significant and the hypothesis has been supported. This study quantifies ProfBuild's ability to reduce cognitive load and execution time for debugging. Our second study is a performance benchmark. The study answers two research questions: how much overhead no workflow will introduce and how much speed up ProfBuild can produce. The result shows that ProfBuilds take a while to start up, or say initialize. Then the debugging and editing cycles are shorter. The majority of this initialization overhead is due to no workflow's dynamic provenance tracking. We treat it as a limitation and future work for ProfBuild. In the next user study, user did voice concerns over this initial runtime slowdown, but not enough to prevent them from using ProfBuild. As for speed up, we categorize three kinds of changes and compared the line of code and the re-execution time between the original script and the script that ProfBuild generated. Even in the worst cases, which say class B, change an input variable, ProfBuild can still get some speed up and shorten the script. Our last study is a real-world deployment. We give user access to ProfBuild for a week and obtain their feedback after they use it. It shows that participants express a preference for using ProfBuild and do not report any significant barrier for individual usage. They also address several issues, and please refer to our paper for details. This evaluation shows the usefulness and efficacy of ProfBuild. To conclude, ProfBuild is a novel use of language-level provenance. It helps users focusing on debugging code and avoid unnecessary changes. It makes it easier for users to reason about code and reduce cognitive load of debugging. And it also reduces subsequent execution time. So ProfBuild can be an easy, effective, and efficient tool for data scientists. Thank you.